Hi, welcome to Vegetable Calculus. In this video, we are trying to determine the area of the face of this mango carton. I couldn't find a vegetable that's exactly of this shape of a rectangular prism, so I'm using a mango carton. Okay, so let's draw the outline of it. The difference between last problem and this problem is that in the last problem, it was horizontal. In this problem, it's actually tilted. Okay, if you recognize this, that looks like the absolute value function. So that's y is equal to modulus of x. So that should be y is equal to positive x or y is equal to negative x. So this equation is y is equal to positive x and this equation is y is equal to negative x. This line and this line are parallel, so they should have similar equations except for they should be separated with a constant. So I'll take constant value 10. Similarly here I'll take a constant value 5. So this completes all the four equations. We also need the x coordinates before we set up the double integration. So the x coordinate is negative x is equal to x plus 10. I'm equating the y coordinates of these two equations. I'll give minus 2x is 10. X is equal to minus 5. Here the x coordinate is minus 5. Here the x coordinate is minus 2.5. Here the x coordinate is 0. And here the x coordinate is positive 2.5. And because it's an area integration, we need double integrals. Remember, for two-dimensional calculus or the area integration, we need double integrals. Okay, but if you took a careful look at this integration, the y coordinate here has one equation and has other equation up top, which is good. And here, after this point, y coordinate here has this equation at the bottom and this equation at top. The top equations are not matching, so which is why we need to split the region of integration here. And similarly, we also need to split the region of integration here. So we actually need three different double integrals. Okay, for the first double integral, I'll use the purple color. So remember, to find the limits of integration for y, we need to freeze x. So I froze this x, say at this point. So limits of integration for y are negative x here and x plus 10. Okay, but what's our main aim? We want this entire area. So to find the entire area, we need to vary our x. X here, x here, x here, x here. And how long can this go on? From negative 5, because it cannot go on further beyond negative 5, till the x coordinate here, which is negative 2.5. So those should be the limits of integration for x. And similarly, for this region, at a particular x, y is varying from negative x to negative x plus 5. And because this should cover this entire region, x should vary from negative 2.5 to the x coordinate here is 0. And similarly, if you freeze an x, y is varying from x to negative x plus 5. And because we want this entire area here, we want x to vary from 0 to 2.5. Area element is dy dx. Because we chose to write the y coordinate first, we need to write dy first. If we chose to write the x limits first, we need to write dx dy. Okay, so if you integrate with respect to dy, you get y from negative x to x plus 10. So x plus 10 minus x gives x plus 10 plus x, which is 10 plus 2x. Remember, the limits of integration for x are from negative 5 to negative 2.5. So 10x plus 2x square over 2. Limits of integration negative 5, negative 2.5. So 10, negative 2.5 minus 5 is negative 2.5 plus 5, which is 5 minus 2.5, which is 2.5 here. Similarly here, x square minus 2.5 whole square minus 5 whole square. So 10 multiplied with 2.5 is 25. 2.5 square is 6.25. 5 square is 25, so minus 25. These two cancel and I get 6.25 as my answer for the first integral. So first integral answer is 6.25. Second integral similarly I'll get 12.5. Third integral I'll get 6.2 12.5 minus 6.25. So this and this will get cancelled. So I'll be left with 12.5 plus 12.5, which is 25. So that should be the area of this face of the carton. You can also do it the other way if you find the y coordinate here. So this 0, 0, this will be 2.5 and this will be positive 5. And the distance between this and this using the distance formula is 5 root 2. Distance between this and this using the distance formula is 2.5 root 2. Remember the distance formula. Distance between x1 comma y1 and x2 comma y2 is y2 minus y1 whole square plus x2 minus x1 whole square, and you need to take the square root of that. So I just use that formula. So length multiplied with width is 5 root 2 multiplied with 2.5 root 2. Root 2 multiplied with root 2 is 2. 5 times 2 is 10. So 10 multiplied with 2.5 is 25. So you'll get the same answer whichever method you do, except for it's good to split the region of integration into 3 regions, as that will be helpful for advanced calculus courses, including calculus 2. Okay, thank you for watching. For next video, I'll come up with a new vegetable. Thank you. Bye.